Okay, it's 11 o'clock. I think it's just about time to get started. This is session ES16, lap around Windows Azure. This is probably a good time to take out your boarding passes and make sure you're on the correct flight. My name is Manuvir Das. I work on the Windows Azure team. And on behalf of the entire Windows Azure team, I really want to thank you for taking the time to come out here to hear us tell you about this new platform. It is for you. I have to admit, just getting started, I'm a little nervous. There's a lot of people here. Boy, this is a full room. And the other reason I'm nervous is that this is only part of my job. The other part of my job is actually to launch this cloud service, which I believe we are doing in another hour. So I have my phone right here, right? No news is good news, but my phone might just ring, right? That would not be a good thing. So let's all hope for that. Okay, to get started, I'm just going to show you the slide that Ray put up in his keynote. This is a slide showing you the entire Azure services platform, of which Windows Azure is one part, the lowest layer, what we call the operating system for the cloud. What I'm going to try to do in the next hour is leave you with three things. Number one, I'm going to explain what is Windows Azure. There's a lot of buzzwords in this. The answer I'm going to give you to that question is, it is an operating system for the cloud. But there's more buzzwords in that statement too. So I'm going to spend some time to explain exactly what that means. And I hope that by the time we all get out of this room at the end of this session, we all have a pretty clear idea of why we think this is an operating system for the cloud and why it's the right one. The second thing I'm going to do is walk you through the key features of the platform, the different aspects that Ray and Amitabh talked about. You all have in your identity cards, you have a thing called a mini guide, which has a list of all the sessions at PDC. As we go through this tour, I'll point out to you the session codes for the different sessions on Windows Azure, and you can just circle them with a pen. I'm sorry we had to do this because we did not want to reveal the real brand name of the product until now, so we couldn't print the real session titles in the mini guide. And then finally, I think an important question, what can you actually do with this thing today? How do you get it? How do you get going? So that's really what this session is all about. So I talked about an operating system for the cloud. I figured the first thing I should probably do is make a pretty clear statement of what we mean by the cloud, right? So it's really a set of connected servers with routers, etc. And what do you do with this? You can do two things as developers. Number one, you can write services, you can install them, which is an important aspect, and then you can actually run them. That's one aspect. And then the second thing you can do is you can store and retrieve data from this set of connected servers. So that's what we mean by the cloud. But before we actually get to talking about the cloud and an operating system for the cloud, let me step back for a second and just talk about a regular old desktop machine, because I think that's a good place to start. So imagine if you were to go build an application for a desktop, just a regular desktop application. Imagine if you were to go build it and run it in the way I'm about to describe. The first thing you do is you figure out what hardware you need. You go find that hardware, you find device drivers for every kind of device you've got on your box. Now you find out that your application actually needs to store some data. So you go write a file system, or you find somebody else who wrote a file system and you figure out how to make it run on your computer. Then you figure out that this application you're writing actually needs to do many different things at the same time. So you need a job scheduler, you need a task manager, right? So you go write one of those. You have to actually run this application somewhere. So you have to figure out what hex address should I load the binary at? How do I actually start executing it? When I run out of memory, how do I bring virtual memory into the picture? How do I swap things in and out? Is there a core that I use? So you go do all of that. And eventually, you get to actually writing the code for your application. And I think all of us in this room would agree that this would be massively inefficient, especially if every single person in this room and everywhere had to do exactly the same thing every day. But this is exactly how we're all building cloud services today. Right? This is literally what we're all doing. Because what is it we do? We start with a data center. Fortunately, each one of us doesn't have to actually go build a data center. We can rent hardware now. We can go to places. But then once we've written our service code and we have it running at some scale, if you think about what we go through on a daily basis, there's a whole litany of things. For instance, we have to worry about, my hardware is going to fail. Disks are going to go down, machines are going to crash. How am I going to deal with that, right? If our services become popular, Steve Marks told you this morning about hellocloud.cloudapp.net, which was his Hello Cloud, and he was just talking to me about how everybody's probably going to be hitting it, so he better go increase the scale of that little Hello Cloud application, right? So everybody has to deal with that. How do you provision new servers? How do you wire them up behind the load balancer? How do you do all of that, right? Normally when you have a service that becomes popular and has more traffic, you find you need to store more data, so you need more storage capacity. That can be a real challenge. Occasionally, we're all developers. We write buggy code, right? We have bugs in our code, so our services fail. We have to have a way of diagnosing these failures. It's always the other guy's fault, but we still have to figure it out, right? So we have to do that. There's an operating system running on every box. Unfortunately, we have security issues, and we have to apply patches for these things. Occasionally, we actually do get the time to add new features, which is what our customers want. But every time you add a new feature, you have this problem that you can't actually take the service down in order to put the new feature in. So you have to do a live upgrade. And those of us who've done that know what a challenge that is. And finally, when your service gets really popular, you want to spread it out. You want to have it be used in Africa, in India, in Australia, where have you. So you can see this is a very long list, and it just doesn't end. And I've put a global tag on this whole set of things. I just call it service glue and operations. And I just realized that I'm being unfair to that side of the audience, so I better go stand here for a while, right? So you do all these things during the day, and finally, at the end of the day, you have a little bit of time left for the blue stuff, which is your business logic, which is why you're in business in the first place, right? This is what we all go through building services today. Now, we know that this is not what we do when we build desktop applications, right? Why is that? What is the answer? This clicker doesn't work from here. Okay. What is the answer when you go to the desktop? It's an operating system, right? And why is that the answer? Because an operating system gives you certain things. The first thing it gives you is an environment to run your applications where you don't worry about the hardware. It's abstracted, right? You don't take your application and say, put it on that hex address and start it. There's a loader that is part of the operating system. You just write the name of your application and hit enter, and it just runs. Right? That's number one. Second thing is you've got a shared file system. It's got access control. Many people can hit it at the same time. That's not a problem. You just take it for granted. There's resource allocation. You run these operating systems are multitasking. You run many different applications at the same time, and they just share resources. And finally, there's many programming environments that come with that you can add onto your operating system and go write your programs, right? So this is the kind of stuff that an operating system gives you, and it's all in a nice package. All these different pieces work together in a cohesive way, so you can just go write your applications. And so this is really exactly what we're trying to do in the cloud. This is precisely what we believe is missing in the cloud, an operating system for the cloud. That's what we've built. It's called Windows Azure. And what this diagram is trying to show is that once you have this operating system, what every service developer can go do is spend a lot of time on the blue stuff. And it's probably not a coincidence that the color of that bar is blue, but you go spend time on the blue stuff and build your business logic, and you spend just a little bit of time on the yellow stuff, or the service glue, because the operating system for the cloud has taken care of a lot of that for you. Some of you who are paying attention will have noticed that on the previous slide, I actually skipped over the last bullet, which was interoperability with other systems. The point I wanted to make there, which I'll make now, is that a good operating system is an open platform, right? It doesn't tie you into a particular way of developing your applications. We believe Windows Azure is a good operating system, and it follows that model. So we believe very heavily in the Microsoft stack. We've done a lot of work with that, with ASP.NET, etc. But it is also meant to be an open platform, so you can plug in other kinds of programming environments as you go. Okay. So a little more detail on what this operating system for the cloud should provide, or what should Windows Azure provide. So I think the first set of things it should provide is exactly the analogs of what the desktop operating system would provide, except that now it's not a single machine you're talking about, it's a set of machines that are working together to run your service. You need an abstract environment. The way you want to run your service is you just type the name of your service and hit go. You don't want to have a deployment team that figures out which machines to run what pieces of code on. That's number one. You want a shared file system that is infinitely elastic. The more you need, the more you get. Resource allocation, so many different people can use the same environment. And of course, programming environments. But there's also some things that are unique to the services world. In particular, we believe that the services world is a little more about utility computing. There's a shared pool of things. You just tap into it. It's sort of like electricity coming to your house. And there's several facets to that. Number one, there's an expectation that it's always up. Right? You can always rely on it. There's always also an expectation that when you build your applications on this platform, you should be able to easily build applications that are actually 24/7 for your customers. Right? The second aspect is it's a shared model, pay as you go. You don't have to buy a big old data center to get going, but as you need more, you just get more. And the third aspect that I think we would all recognize is these machines in the cloud are remote. So a lot of the cost we pay in terms of a TCO is how to actually manage and administer these machines. And any good operating system for the cloud should go a long way towards addressing this problem. So in conceptual terms, this is what Windows Azure is trying to provide. And I think this is probably the point where you're all saying, he spent too many minutes on all the mumbo jumbo and show me something more concrete. As a service developer, what does this actually mean to me? What are the features in this thing, right? So that's my next slide. How does this actually map to features? So there's 4 main features in this platform. The first is automated service management. The way the system works is you write your code, you define the rules, and then you hit go. Based on the rules, Windows Azure will take your code, deploy it on all the right machines, start up all the machines, set up all the routers, load balancers, etc., and get your service going. And not just will it get it going, but it'll also manage your service for you, and I'll come back to that in a minute. The second aspect is a powerful environment for hosting your service, for actually running your code. Where does your code actually run? So we've got all the hardware, all the servers, the load balancers, the routers, etc. And we've got environments where you can run directly on the box, environments where you can run virtualized under the hypervisor. As Amitabh mentioned in the keynote, it's a hypervisor that's specifically optimized for the data center, for these machines. One advantage we have is we know what machines are in there because we put them in there. Right? The third aspect of this platform is a scalable and available storage in the cloud. The idea here is that you should imagine it to be an infinitely elastic file system in the cloud. There's a few simple abstractions like blobs, tables, and queues that service writers find useful. And finally, we are Microsoft. We are a developer-oriented company. That's fundamental to us. We've spent a lot of time on the developer experience. In particular, we've spent a lot of time on the entire life cycle of how do you go from thinking about your service to developing it and debugging it to actually get it going in the cloud. And one of the things we've done to make this experience go is we've built a complete simulation of the cloud that you can run right on your desktop. And you can do everything you would do in the cloud run on your desktop. And just to emphasize this point, I'm going to give you a little demo of how this thing works. So I have a simple service which I call the thumbnail generator. This is a picture of the conceptual architecture of my thumbnail generator service. What it's got is there's a bunch of these things called web roles, which are just some ASP.NET code sitting behind a load balancer, and they're taking some requests where they're taking in pictures. And they're putting those pictures as blobs into this cloud storage system. And then I have a set of worker roles that are asynchronously just sitting there and looking at these queues. The queue is also in the cloud, and it's picking these requests for photos of the queue, and then it's generating thumbnails with some code that's written in the worker role, and then those are getting displayed again, right? And the box that you see, the white box, is meant to designate the service itself. And all of this is actually running on my desktop in this simulation environment. So let's switch over there. So what you see here is my browser, and I've just got this service running locally. And I'm going to start up this thing that we call the developer fabric, which is my simulation environment. And what it shows is I've got this service called thumbnails. you see 5 different console windows because I've got a web role and a worker role, and I fired it up with 2 instances of the web role and 3 instances of the worker role. Okay? Now, what I'm going to do is I'm going to go back to my browser, and I'm going to try to pick up an image of which I want to make a thumbnail. Can I hit submit? And the worker role did its job, and a thumbnail came up. We can talk more about that picture in a minute. So now I go back to my console over here, and you'll notice that there's actually some spew now on these windows. And what's going on here is, if I look at the web role, one of these web roles processed the request and pushed it on the queue. I've just got a little spew there saying it went to the queue. And then if I look at the worker role, one of my instances, actually instance 1, actually picked the request off the queue and did its work. Right? Now I could go back here and let me refresh this page a few times so that this action happens a few more times. So I'm just reposting this thing so that service gets activated again. About one more. Five shoes, okay. If I go back to the developer fabric now, and if I look at the web role, now you'll notice that what the load balance in the simulation has done is it sent 4 of the requests to one instance and 1 request to the other one. And if I look at the worker role, I'll find that, I guess, a couple went to instance 0, a couple went to instance 1, and to instance 2, and so on, right? So what I'm trying to show you here is this is a complete simulation environment on your desktop. You could be doing this on your laptop on a plane. The storage system, everything is built in. And one of the fundamental issues that people face when they move to the cloud is you've got multiple instances of things. You've got multiple front ends talking to the same store. You've got multiple worker roles picking things up off the same queue. You don't want to find the concurrency problems you might hit for the first time when you get to the cloud. So this is an environment where you can do all of this back on your desktop. Okay, and that demo worked. So I'm not as nervous as I was. Okay, yeah, you can clap for that. Come on. Yeah, thank you. Because, you know, the secret is I don't have the latest bits. I discovered that last night, and the team yelled at me for that. So I'm glad it didn't fail. Okay, so let me take you on this little tour now of the different features of the platform in some more detail. Let me start with automated service management. So what we're talking about here is the complete service lifecycle. And the way this works is the first thing you do as a developer is you develop, you write your code. But in addition to that, you write down this thing called a model. Now, what's in this model? 3 things. One is, what does my service actually look like? What's its topology? Do I have front-end roles, back-end roles? Do I use cloud storage? How do they talk to each other? How many of each thing do I have? That's the picture, really, that I just showed you for the thumbnail generator. Just a picture like that. The second thing I describe is, what does it mean for my service to be healthy? Because only I, as the service writer, know what it means for my service to be healthy. For instance, I could say, deploy my service with 20 front ends. But at any time, if 5 of those front ends go down and I have 15 front ends or less, I'm in trouble. I need an alert, right? My service is unhealthy. That's the kind of thing. And then finally, the configuration settings, which is what are the values, the name value pairs, if you will. What are the values I want to change at runtime without actually having to redeploy my service? Once you've put all this down in the model, Windows Azure takes over, and it has enough information now to go deploy your service. So you just write the name of your service and hit enter. The loader underneath takes care of everything, figures out where to deploy your service. We've got a model of all the resources in the cluster, who's using what. We can find the right place to host your code depending on all your requirements and just launch it up. That's almost the easy part. The harder part is actually keeping your service running, maintaining its health while it's actually running. That's really the fun stuff. So I have a slide just to talk about that fun stuff, maintaining the service health. Right? So what is it we're trying to achieve here? We're trying to make sure that once your service is up and running, as things fail, as hardware fails, as your code crashes if there's bugs in it, or as you go through upgrades, whether it's upgrades in the service code or it's upgrades in the operating system, your customer should not know, right? Your customer should not care. That's the goal we're trying to achieve. So how do we do this? The first thing we have to be able to do is detect failures, find out when your service is actually unhealthy. Part of this is on us. We can watch every machine. We can watch how your service is running. Part of it is on the service rider because you put those constraints down telling us what it means for a service to be healthy. Once we've detected these, we have to have a way of transparently fixing things up for you. If one of your front ends goes down and it needs to be replaced, we have to have a way of spinning up a new instance, rewiring the load balancer, right? If you have a pool of backend machines that you're talking to and one of them fails and we need to bring another one up, we need to reset your code in a certain way so you can keep talking to the new machine that replaced it. So the trick to this is abstraction. So we have a model here where we've tried to raise the level of abstraction a little bit. In particular, what you do in your service in this model is you declare the logical resources you need. So you don't say, I need server, and that server. You say, I need 10 of these, right? And then what we give you as part of the platform is we give you a few APIs that you can call to map those logical concepts into actual physical entities like IP addresses. And then you just go use those. So you can still use your regular developer experience. You can use all the standard APIs and all of that. But you had to call certain APIs to actually do the mapping from the logical things you wrote in your model to the physical things you can use in your code. And because you did that, we are able to bring in new machines, replace things, notify you when a particular IP address is no longer valid, so you can make the API call again, etc. You can call these APIs. So really, the point I just made here is that it is a world where we say, if you do a little bit of abstraction, it goes a long way towards making your service manageable. So that really is the bottom line, right? It's a balance between two things. Power. Give me the box. Let me do whatever I want on the box versus ease of use. We want you to be able to build services where there truly is an operating system available that helps you manage your service, right? You write well-behaved services as per the model, it's going to reduce your TCO, and I think that's probably a good thing. At the same time, the model has been designed in such a way that it caters to a wide variety of scenarios, from the hobbyist in the garage all the way to the enterprise developer, and we actually have a session at lunch, I believe tomorrow, where we talk about how the live meeting team is using this operating system to do an enterprise level application. At the same time, we do recognize that there are some scenarios where you really just want to get to the box. We call that an escape hatch. We call that raw mode. So we do have this concept where basically you get to build your own VM and deploy your bits. But under this situation, it's a little difficult for us to come in and manage the service for you. So that's the catch with that. If you need more information on this whole topic of automated service management, there's two talks I'd like to highlight. Yusuf Khalidi, who's the architect of this service management system, will be talking about architecting services in the cloud. That's ESO2. And then we'll have an under the hood where we actually talk about this fabric controller and how it does all this stuff for you. Okay. The next aspect I want to cover is storage in the cloud, scalable, available cloud storage. The concept here is we've picked a few storage abstractions that we believe are fundamental to people who are building services. Sometimes you want to store these items of user data that can be very large. So you need blobs or you need file streams. Sometimes as a service, you want to store metadata. What's the information about my customers? Who's checked out what videos? So you need simple tables. You need caches to help your services deal with load. And sometimes you build services by building them in a loosely coupled way and letting them communicate with each other with things like queues and lock servers and the like. So that's what we've got in our storage system. You'll notice that some of these things are in white and some of these things are in gray. And the reason for that is the things in white are available today in the tech preview, and the things in gray are not being exposed yet. I think Amitabh mentioned in his part of the keynote that we have a philosophy here that we are doing this release in a staged fashion. So we're releasing some things now, exposing some things now, and some later. The way to think about the storage system is it's all about scale, massive scale. You should be able to have tens of thousands of tables and millions of rows, and these should be spread over thousands of servers all over the world. High availability, this should be the way you get your highest availability for storage. And of course, durability, your data should never disappear, right? Those are all points of emphasis for the storage system. In addition, we believe very strongly in geo-distribution and geo-replication. And those are features of this storage system as well. Again, those are in gray because we're not offering them as part of the technical preview. One thing I want to stress about the cloud storage system is this is not a database service. This is not a thing you can use to build your relational tables and do joins and data warehousing and all of that. Ray alluded to a different service we have as part of the overall Azure Services Platform, and that's called SQL Services. And that's the place where we provide the database service in the cloud. If you want to know more about our storage system, you can attend ES04. Brad Calder, the architect of our storage system, will explain to you all that it can do. And then ES07 is a dedicated talk on how to program tables. Because even though these tables are not a full-fledged database, we have made them easily programmable for you. You can use ADO.NET Data Services as your way to talk to these tables, and we have a session on that. The final aspect I want to talk about is the developer experience. I've already showed you the simulated cloud environment that you get on your desktop. That's number one. We think that's a big part of the service lifecycle. In addition, this is an operating system. It is an open platform. So we have support for a variety of different programming languages and environments. Today in the tech preview, we offer you ASP.NET and .NET languages when you code your worker roles. We also support native code in the platform today, but again, this is a staged release, so we are not exposing that at this moment in the technical preview. Microsoft is already working on supporting PHP on Windows Server, so we will, of course, support PHP in Windows Azure, but that is not something we're exposing in the technical preview. This is Microsoft. We are a developer company, so we have a whole ecosystem of tools and support. You will see a session where we'll talk about the integration we've done with Visual Studio, all the way to bring up a solution, hitting F5, doing your debugging, all of that. At the same time, it's an open platform. Windows Azure comes with its own SDK, which has a completely open command line interface. You can build an Eclipse environment on top of that. We have actually done that, and in a later session, we'll give you a demo of how we put that Eclipse environment together, and you'll be able to see us building a service with Eclipse and all of that. There's all the usual samples, documentation, etc., forums. We have a team full of people who are eagerly waiting to help answer your questions. The point in the middle about logging, I think anybody who's built a service in the cloud would recognize that when you've got a real live thing running out there being hit by many developers and something goes wrong, you don't want to step into a debugger. That's a really bad idea. So people typically do logging, both proactively to find out when things might be going bad down the road, and retroactively when something does go back. So we've built a whole system for logging in this operating system. There's a few APIs you can use to dump your logs at various levels of severity. We've got a back-end system that collates and collects all these logs and stores them for you in the cloud storage, and then you can go to the portal and you can grab these logs and do what you want with them. We've got a system for alerting. It'll wake you up, call your cell phone, etc., if something goes bad with your service. And finally, we have a system for tracing where literally you can take a request coming into your front ends and you can watch that one request filter through all your servers and all your roles. And that way you can connect actions that happen in one place with another. And that is also in gray because that's not something we are providing the technical preview, but that is something we have been working on. Okay? So this is a brief tour of the different aspects of the platform. What we've tried to do is put this all into a package that we think of as an operating system for the cloud, which allows any business to go really build their business and bet their business on this operating system. So I thought what I would do is have one of our partners come up here and share with us a little bit about how they did that. So I'd like to welcome Danny Kim. Hi, Danny.
So let me switch into a quick demo. I'm going to give you a teaser demo of an application a product that is currently selling, that we actually sell as an on-premise solution. We had the privilege of being on one of the early adopter programs for the Windows Azure program. And so we built this, we actually ported our product over on top of Windows Azure. And it took us about a month to month and a half. Now, while we were doing this port, it just so happened that we actually closed or got a customer, one customer, and it happened to be the government of Ethiopia, which was a little bit larger than the typical customer we would get. This is an actual Silverlight application that's all actually running in the cloud currently. If you actually look at it's actually live in the cloud. Please don't go to the site because we are managing the Ethiopian teachers live at this point. We actually integrated with live maps so that we can actually see GPS coordinates from their teachers' laptops coming to us. If you look at actually any of click on any of the laptops, you actually will get GPS coordinates, longitude, latitude, as well as the operating system details. We actually have an agent on the end desktop sending up information, and we're storing that in the cloud. Now, the neat thing about this is Policy Portal was designed to do endpoint management. So not only can we get feedback data back from the endpoint, but we can actually send packages down, which is actually was very critical for the Ethiopian government. They needed the ability to push down applications, push down policies to lock down. Some of the teachers have never seen a Windows Vista machine ever before in their lives. And so there's some areas that they wanted restrictions and security and protection around it. We can actually send documents down, private teacher documents that have been encrypted and secured over the cloud. And the neat thing about this is we developed this application once, and we designed it just like what Manuvir said. We had a front-load service and a back-end role that actually was able to scale because all of the endpoints that are connecting is load balanced. And so we deployed this initially for a 20-person pilot, and at the end of the month, we'll actually have 150 teachers running. And we signed, when I demonstrated this to the Ethiopian government, the cabinet, they essentially the next day said, okay, we're ready to sign because we know now this application is scalable because we want to deploy this to 250,000 teachers throughout the country. So that was kind of interesting take at this because what I did was I actually went to Ethiopia after we did the port, and I took this picture. This is actually the data center in Ethiopia in the government offices. This gentleman here that you see, his name is Kiros Bito. He's the head of all IT for the district of Tigray for Ethiopia. And they're very proud of this data center. It's a very nice rack, but they could barely run the 100 to 200 employees that they have in their government offices. And the prospect of actually doing a system or supporting a system where they had to manage 250,000 teachers was just completely impossible for them. And when we showed them this technology, they were just so thrilled about it because essentially they said this is now a feasible technology. Because if you look at the Ethiopian environments, you know, when you go back to the map, you'll see actually this is actually the live map, and I know there's a Sheraton hotel right here. The only hotel in all of Ethiopia that has an ATM is that one Sheraton. So the infrastructure there is very limited, and they have rolling blackouts throughout the country. And so for them to have the ability to have this cloud-based service that allows them to manage all their endpoints was critical. So I just wanted to give you this teaser demo and invite Manuvir back up. And then I'm actually going to cover this in more details in another session. And Manuvir, if you can take the reins back. Thank you.
Thank you, Danny. You know, I'm going to leave that picture up for a second because they say a picture's worth 1,000 words. And I think this picture really tells the story of Windows Azure very well, right? Because these people are now plugged in to a massive data center, and they can just change a 5 to a 10 or a 5 to a 50, and they've got as many machines as they want, right? Thank you, Danny. Okay, so I think the service that Danny just showed us is unique in one sense because it's his business that he built for the Ethiopian government. But in another sense, it's actually very generic. And it's very representative of the kind of service from a technical point of view that many people build in the cloud. And really, that's what this platform is about. So I thought I would take a minute or two to put this picture back up to you. If this picture looks familiar, if it looks like the picture of the thumbnail generator, that's no accident. It is. It's the same architecture that Full Armor is running for the Ethiopian government that I was running for my thumbnail generator, right? Those of you who saw the picture very carefully the last time will have noticed, however, that there are a few changes in this, and let me point those out. That box in white now is the service, and everything outside of it is the public internet. And I've added some of these white arrows to explain how that works. So the first thing about this service is there's a load balancer, which is taking inputs off the public internet and feeding them to this web role. And I can specify this value of n, and I get as many copies of this web role as I want, and they're all distributed behind this load balancer, right? That is the only way input is coming into my system. Nobody out in the world can hit an IP address of any of my boxes directly. They come in through this load balancer and hit one of my published endpoints. This web role is talking to the cloud storage, which is also provided by Windows Azure. Notice that that edge is actually a dotted edge, and that's meant to say that this is not going out to the public internet, right? This is the same system that is hosting your data and running your code, so you have some co-location here with all the benefits that implies, right? You get lower latency, you get higher throughput, it's probably going to cost less, etc. Then we've got the worker role. You can have as many instances of that as you want. I just put the value M over there. This thing is also talking to the cloud storage. Think of the cloud storage as this infinitely big bus of data that I've got. And again, it has the same co-location benefits. Notice that there's no other edges coming into this. So there's nobody hitting this worker role. What it's doing is it's just sitting there. It's like a main in a loop, and it can pull things off the queue, or it can do something else. It can, it can be running stock codes or what have you. The first new edge that I put in here in this diagram was, if you look at the cloud storage box, you'll notice that it's got a bidirectional edge out to the internet. What this is saying is that our cloud storage system is accessible from anywhere. It's got REST APIs on it. You can store and retrieve data from this cloud storage system from anywhere, and there's various reasons for providing that facility, as you can imagine. When you're debugging your applications, it's very helpful to do that. You don't have to run in our cloud. You don't have to host your code in our cloud to actually access the storage system. You can be running somewhere else. You can be running on-premise, what have you. It opens up all kinds of scenarios. The other kinds of edges you'll notice is from both the web role and the worker role, there are unidirectional edges going out to the internet. What this means is any of these pieces of code you've got can open a TCP connection to any box in the world, right? It's up to you. You can go talk to whichever thing you want and however you want, right? So the key points I wanted to make with this picture are, number one, this architecture is an example of an architecture that represents best practices for how you build cloud services at scale. You don't scale up, you scale out. You have a bunch of stateless compute nodes. You can any of those machines can fail at any time, and it doesn't matter. Your service is going to still run because there's no data that's stored in only one place. Any data that is persistent, you just put in the cloud storage system. You have a local disk, but you use it as a cache, right? That's one best practice. The second thing it shows is that it's useful to build loosely coupled architectures. That's an example right here. These front end and back end are talking to each other through a queue. It's a reliable, fault-tolerant queue in the cloud. The set of web roles just dumps requests into the queue. The worker roles pick them up. If a worker role picked up a request and that worker role died before it sent a message back saying it's completed the request, this queue system in the cloud is just going to materialize that request again so that another worker role that is still existing can pick that request up. That's how the system is built, right? So it's about best practices. The second thing I wanted to show with this picture was that this is an open platform, right? In terms of how it runs, you can access it from anywhere. You can reach out to anywhere else. And you can envision all kinds of scenarios where you have some code running in our data center, some code running somewhere else. Full Armor is actually a great example of that. We have a session ES29 where Danny and his colleagues will actually walk us through more details of the system they've put together. I'm going to cheat a little bit and show you another slide here, which actually says exactly what I just said verbally. Don't bother reading it. The reason I put this slide up is because I know there's going to be some people out there who are going to flip through the slide deck without actually coming to the talk. And I wanted to put these talking points out there for them. It's not needed for you. You already know everything I said. There is one point I want to make, which is at the bottom of the slide. We felt that it would actually be a good idea to have a session at the PDC which is exclusively about these best practices. What have we learned about the best practices of how you do cloud services? And for each of these best practices, what is Windows Azure doing to encourage those best practices, to support them, and in some cases to actually push you in the right direction so that you follow those best practices. ES03 is a session that is dedicated to that, and I encourage you to attend that. Okay. I spoke a little faster than I had intended to. If I had done this properly, it would be noon. And I'd be saying the technical preview starts now. Right? Now, the good news is my phone hasn't rung yet. That's good. The bad news is technical preview starts in 20 minutes. How about that? Okay? What you can do for the next 20 minutes, though I would not encourage you to do that because you're all supposed to be listening to me. You can go to azure.com and you can start reading up, but you should not be doing that until my talk is over, okay? The technical preview starts in 20 minutes. The first thing in there is this desktop SDK with the full simulation of the cloud. This is out there at noon. You don't need a live ID. You don't need a credit card. You don't need anything. This is a free download. You can go get it. It is the complete simulation environment. You can start building your applications today. Anybody can do this. There are zero restrictions on this whatsoever. Right? The second thing we've got is the preview of the cloud. This is a limited preview because we have a certain number of machines in the data center. It's a very large number of machines, but nonetheless, everybody who gets access gets free usage, although there are quotas as to how much you can do, as you can imagine. You're all here at PDC. You are our best customers. You've all paid here, paid to come here, and more than that, you've all taken the time to come and hear us. So you're all at the front of this queue, and you can go sign up through Connect if you haven't done that already. You'll get on the list, and sometime within the next 2 weeks, you'll get a piece of email with your token and instructions on how to redeem that token. We're going to start that process today. That's the sense in which it's opening up at noon. So some people will get their tokens today, and you can start playing with the system. What's actually in the preview in terms of features? All of your application code will be running in virtual machines. The reason we've chosen this model to start out with is because this way you have a guarantee of what kind of resources you're getting that your application is running under. So every instance of every role is running in its own VM. You've got a dedicated CPU. You've got dedicated 2 gig of RAM. You've got a dedicated hard drive that you're not sharing with anybody else's code in any way. So you have a good mental model of what you can program to. All the service management stuff, these architectures that I showed you today, ASP.NET and managed code. For storage, we've got blobs, tables, and queues, and it's all in a single large data center on the US West Coast for the tech preview. We are very much on the way to creating many more data centers in different places, and for anybody who's been in the business of doing that, you know that if you need a data center tomorrow, you don't start thinking about it today. So you can imagine we've done a lot of this groundwork already, right? Trucks are moving, have already moved, et cetera, et cetera. Okay, this is all just the first step towards the eventual commercial release. When is this release going to happen? It's going to happen when you tell us it should happen, right? You're the ones who are going to tell us we're ready. But at this point, we anticipate it should happen sometime in calendar 2009. I've listed on this slide the 3 big things that we think you'll get with the commercial release that you don't get with the tech preview today. Number 1, a business model, which will be based on consumption-based billing with SLAs and financial guarantees. So if we do something bad, which we will not do, but if something happens, there's an SLA, and you have recourse. Second thing would be global reach. We'll be in many different data centers. We'll have geo-distribution, both for your computation and for your data. So you'll be able to choose where you want your data to reside, where you want your service to run, et cetera. And in terms of service hosting, we will support native code. We actually run native code today, every day, in production in our data centers. It's just we're doing this in a staged fashion. And you will have more complex service models. I should actually point out that our cloud storage system is, in fact, just a service that has been built, bootstrapped on the system. I think Amitabh showed a picture of the service model for the cloud storage system. That's how we've done it from day one. It is, as you can imagine, it uses native code heavily. It uses all the complex kind of things you might imagine a distributed storage system to do, right? It uses disks heavily, et cetera. So that'll all come. One point I do want to make here is this is the services world. So you should not have the expectation that we've done a release today and we'll go away and we'll come back sometime in 2009 and we'll say we've got a V1. What's really going to happen is from now onwards, we've got a system up in the cloud. It's what we think of as live. We'll rev it. We'll rev it frequently. Not every day because that'll be destabilizing to you, but frequently. And that'll keep happening. And at some point, we'll get to the point where you tell us that we're ready to launch something that we call a commercial release, and we'll do that, and we'll go on from there. That's the model, right? So to summarize, what is Windows Azure? What are the 3 things I would like you to remember walking out of here? It is an operating system for the cloud. It does, for a set of servers, what traditional desktop operating systems have done for a single machine. That's the sense in which it's an operating system. It's an operating system by analogy. It's designed to support utility computing. You pay as you go. It's always up. It's like the electricity coming to your house. You already know the key features it has. A quick call to action. The technical preview starts in 15 minutes. If I talk long enough, we can make this work. Okay, it starts in 15 minutes, so go get it. Just go to azure.com. Hopefully the link should be helpful. I'd encourage you to attend all the Windows Azure sessions. I have to let you into a little secret. We did this thing in our team where we produced these flyers, these cards that you could put in your pocket. We got a whole bunch of people in here this morning, bright and early. We had 2,000 of these. And we started putting them on every chair so that I could tell you, you know, if you look under your chair, there's one of these session lists. It shows you all the session lists for Windows Azure. We started doing this, and a few minutes in, I just picked one of them up. And I noticed that we had the wrong sessions on there. So we did what people in the services world would call a rollback. We just pulled those back, put them back in the box, hid the box under there. The box is actually, look, I've got the box here. It says FedEx Kinko's. Okay? So we put the box back, and there's no session list. Okay? But if you go to those mini guides that you've got, look for I think I've pointed out some of the sessions. If you go online to the website now, all the sessions have new names. They'll all have Windows Azure in their name, and you can find them that way. And please go to the hands-on labs. We've got many, many people from my team that are excited, and they'll help you use the system. Before I end, I have this slide to put up. You can put your evaluations and et cetera, and view the recordings and all of that at microsoftpdc.com. So that's basically my presentation for today. I'd like to point out that I finished a little early. Hopefully you see that as a positive. And I want to thank you for your time. Thank you.